Hi, Math 1, Mr. Bruns here again. In the previous video, we talked about solving absolute value equations. Today, in this video, we're going to talk about solving absolute value inequalities. So the big difference we see here is that we have an inequality here, a less than sign instead of an equal sign, instead of an equation. And this is why last week, when we were solving single variable with inequalities without the absolute values, we wanted you to tackle things a certain way where we wanted to find those boundary points and then test values on either side of those boundary points. This is why we had to do it that way, because things are going to get a little messier here. We're going to go through a couple of examples and hopefully things will make sense. Okay, so like we did last week, we are going to first turn this into an equation, which is what the previous video just showed us how to solve the equation. So we're going to make this 2x minus 5, absolute value of all that, equals 6. We're looking for those boundary points. So if you remember, the stuff inside of the absolute values has two options. Either this stuff is equal to 6, or what's in here, this stuff is equal to a negative 6. So we're going to solve those two equations. This is equal to 6, or 2x minus 5 equals negative 6. All right, so we solve these. I'm going to add 5 to both sides. So I have a 2x equals 11. Divide by 2, and I get x equals 11 halves, or 5.5. Over here, if I add 5 to a negative 6, I get 2x equals negative 1, and divide by 2, I get x is negative 1 half. So those are the things that would solve this equation. Those points, those x values, become the boundary points for our inequality. And so we're going to go to, maybe I'll draw it out on a number line here, where I always just like putting 0 somewhere. So there's my 0. Here is 11 halves. Oops. 11 halves, which is 5.5. And over here is a negative 1 half, which is a negative 0.5. And what we need to do then is we need to test values back into the original inequality. I'll write that right here so you can't see it anymore. This was a 2x minus 5. Absolute value of that is less than 6. And so I'm going to pick, now I have, because I have two different boundary points, what I have is I have 3 different regions that I need to test. I've got this region that is to the left of negative 1 half. I've got this region all in here that's in between the two boundary points. And then I have this region over here, which is to the right of that 5.5, or the 11 halves. So I'm going to test a value from each one of those. Over here, an easy value that is to the left of negative 1 half, I think that I can plug in, is going to be negative 1. I'm going to try negative 1. In between negative 1 half and 11 halves is 0. I love testing 0 because it's super easy. And then something bigger than 5.5 that might be easy, I'll plug in 10. It's easy for me to multiply things by 10, so I'm just going to pick 10. Okay, so here we go. We're going to test all of those to see if they make our inequality true or false. All right, so I'm going to try them right here. I'm going to say, what if x is negative 1? If I test that, I'm going to get absolute value of 2 times negative 1, negative 2 minus 5. Is that less than 6? That's the question. Well, negative 2 minus 5, that's a negative 7. And absolute value of negative 7 is positive 7. So is 7 less than 6? No, that's false. Okay, so over here I tested something to the left of negative 1 half, and I got something that was false. I'm going to put an F for false. All right, so let's try x equals 0. Try x equals 0. I get absolute value of 0 minus 5. Is that less than 6? Is the absolute value of negative 5, is that less than 6? This gives me 5 is less than 6. Is that a true statement or a false statement? And clearly that is true. So I tried something x equals 0 that was between those two values, and I got a true statement. All right, let's just check one more thing here. We're going to check x equal 10. So if I let x equal 10, then I'm looking at the absolute value of 20 minus 5. Is that less than 6? 1, because it was 2 times 10. 20 minus 5, that's 15. absolute value of 15 is still 15, and is 15 less than 6? Nope, that is not true. That is false. And so we find that regions beyond the 5.5 are false. So we want any of the places that will give me a true statement for this inequality, and it looks like any x value between these two boundary points will give me a true statement. And so the way that I can write that is I can say this works as long as x is bigger, greater than -1/2. So -1/2 goes here. X is greater than -1/2, but x has to be smaller or less than the 11 halves, 5.5. 11 halves. Should I include the, is this an or equals to or just a less than? In this case, because the original problem had strictly less than, not less than or equal to, our final answer will just be -1/2 is less than x, which is less than 11 halves. And the way that we can show this on a number line, I'm going to make this a little cleaner here. I'm going to put my -1/2 there. I'm going to put my 11 halves here. We're going to use open circles because I'm not including the boundary points. It's not a less than or equal to. Open circle here, and I include everything in between the 2 points. That's what my solution looks like on a number line. So this right here, and then this is what my solution will look like when I write it out in terms of x. All right, so let's tackle one more example here. I'm going to go through the same process. Here's our problem for this one. Absolute value of 5x plus 4 is greater than or equal to 11. Remember, the first step in all of this is we're going to take 5x plus 4 and make it equal 11. So the absolute value of 5x plus 4 is equal to 11. No longer inequality. Now we just have an equation. And we have two options. The thing inside is either equal to 11, or the thing inside is either equal to -11. So we're going to try both of those. I'm going to say, what if 5x plus 4 equals 11, and what if the 5x plus 4 equals -11? If I subtract 4 here, I get a 5x. 7 divide by 5, and x is equal to 7/5. I think is equal to 1.4. And then if we subtract the 4, we would get 5x equals -15. -11 minus 4 is going to be -15. Dividing by 5 gives me x equals -3. Here are my 2 boundary points. These are the things that will make this equal to 11. But I need to figure out when will this absolute value thing be greater than or equal to 11. And so we're going to show us what all this looks like on my number line again. So 0 is sitting somewhere around here. Here's a -3. Here's a 7/5, which I think is about 1.4. And I need to test some value. So something that is to the left of -3, maybe I test -5. Something between -3 and 7/5. Again, anytime I get a chance to test 0, I'm going to try 0. Something bigger than 7/5. 2 is bigger than 7/5. Like I said, 7/5 is just 1.4. So those are my 3 values. You may choose different values. You might pick 10 as your value to test over here. Maybe you tested -4, or maybe you plugged in 1. It's your choice on what you want to test. I just need to pick some x value that's in between here and here. Some x value that's bigger than 7/5. Your choice on what it is that you want to actually test. Just make sure you're clear in showing your work and all that. Okay. So again, our original inequality was absolute value of 5x plus 4 is greater than or equal to 11. And we're just going to test some of these out and see if we get true or false statements. So I'm going to start with x is -5. So that means I'm looking at 5 times my -5. It's going to be absolute value of -25 plus 4. Is that greater than or equal to 11? That gives me absolute value of -21. Greater than or equal to 11. And absolute value of -21 is just +21. Is 21 greater than or equal to 11? Sure is. That's true. Okay, so that worked for me over here. This region over here was true. All right, we're going to try x equals 0. We plug in 0 for our x's. So I have a 0 plus a 4. So absolute value of 0 plus 4 greater than or equal to 11. Is the absolute value of 4 greater than or equal to 11? Hopefully you can see. Nope, that is not true. That is false. So we got something false in between here and here. Try one more. We've got a test x equals 2 is what we decided on, but again, you might have picked a different value. This is going to be absolute value of 10 plus 4 greater than or equal to 11. That's absolute value of 11 is greater than or equal to 11. Is 14 greater than or equal to 11? Yep, that's true. That 14 is greater than or equal to 11. And so we get something true for this region over here. So this one's a little different. On the previous example, it was the values in between the two boundary points that worked. In this case, it's now the values outside of the boundary points that are working. And so to write that, we would say our solution will be any x value that is less than -3. Okay, -3 was that boundary. Anything less than that, or any value that is greater than 7/5. So anything greater than 7/5. Now, should I include the -3 and should I include 7/5? And the answer is yes, because I wanted things that were greater than or equal to. So because of that or equal to part there, we would say I'm okay with anything where x is less than or equal to -3, or x is greater than or equal to 7/5. So one last number line here, what our solution would look like on the number line. Here is my 7/5, here is my -3, and I had any value to the left of -3, and since I was including -3, I will use a closed circle, a filled-in circle, and over here at 7/5, I'm going to use a closed circle, a filled-in circle at 7/5, and anything to the right. So the solution here looks a little different in that we're including the values out towards the ends, to the left and the right, whereas on the previous problem, we had a solution where everything was in between the two boundary points. All right, so hopefully that helped you in figuring out how to solve these absolute value inequalities.